hello everyone. October 16th. Alright, let's finish today, and then I have to go back to the minimum difficulty thing because I need to. No, this is fine. We've done it. I need to read through this stack solution. I need to see how it can be done in OND. Right? It's necessary to just kind of take a look at that. We'll do this later. So let's go to this. This is today's challenge. Check if the sentence is pangram at least once. Okay, so we'll do this very fast. So what type of method are you thinking about? Well, I'm thinking about set. I think set shall be the easiest way to handle a problem like this. So we can say len set sentence is equal to 26. I think that shall do. Yeah, I shall do. One 8 3 2. Okay, so we're done with this. Now let's take a look at did I even explain bottom up? Let's just read. This is true, right? Which means the number of jobs is smaller than the number of days. And then we have two DPs. Okay. For D in X-ray, so for D in D, stack from D to N. Plus AI. While stack. Doesn't make any sense. This is said if I have 1 day, a 0 day, right? If I have a 0 day, then what? Then this. Everything is infinite at the beginning. And while stack, actually stack is empty. If stack, nothing. So stack dot append I. Alright, I think somebody did an explanation and to read this. Stack keeps the index of monotonically decreasing number in A. When checking AI, assuming that the last number that is larger than AI is AT. Possible cutoff index in T to I. We need to check possible cutoff in a corresponding code. if a the stack pushes index. If this is smaller or equal to, then we'll pop. Because the current one is bigger. Current one is bigger. Is it monotonically increasing? Oh no, decreasing. dp2j minus aj. What the hell is j? J is the popped. Then plus, which means we'll swap to ai. If stack. Huh? I don't understand. For each what's dpi? Should be the I think the dpi, let's call it dpi, is the minimum difficulty for working, right, for d days up until ith job. How about that? That's what dp. So dp minus 1 is the final answer. Yes. Okay. So we say this will be working for 0 days. Everything is infinite. This is working for 1 day, but we haven't done anything yet. Right? We haven't done anything yet. Working for 1 day. No, this is working for. Or is that working for 0 days? Basically, we start with 0, right? This is 0. This is 0 day. And then I go from D to N. No, we start from 0. So 0 day, we say we go job. First job all the way to the end. And we say DPI, just for the first job, with 0 days, is going to be first job with 0 days. That is not 0 days. That's the first day. We're trying to figure out what's the first day is going to be. So each day we're going to be is, say, the previous day. Okay, so for the ith job on the day, I want to know what's the difficulty for this day. So to know that, I will check, right? I check the previous job and the previous day. Check the previous job and the previous day. and the previous job and previous day. Now to check, we just say, okay, let's just take a look. The previous job of the previous day, what's going to happen? Then we say it's going to be the previous job and previous day plus AI. Yes, because I say the current one is going to be a new job, right? It's going to be the new day on the new job. So this is kind of temporary. We set up dp2, right? And then we go on to the stack, okay? So the stack is monotonically decreasing. And we say if the current job is bigger than the previous one, whatever previous job is in it, so now we pop it. And that previous means from this previous to the current, everything in between is smaller than both. So I say when I pop this, then let's say on the jth job, right? On the jth job, we have the current day on the jth job, right? The current day. Let's say if we had the current day, we did the jth job, the minimum difficulty is this. But now I say instead of doing that job on the jth day, I can cover the job because the difficulty of my current work is more. So I can cover for you. So I can cover for all of those. So as I cover, that means dp2j, we don't have to take aj, because aj back then is the highest difficulty, right? It's the highest difficulty. But for now, I say, okay, I don't want to repeat it calling the highest difficulty, so we'll include that in the same day. So we'll say d2j. Yeah, I mean they are on the same day. It's on the same day. On this day, what is the difficulty for job at the jth job, right? It's all on the same day. So you say if on the same day, so we do AI and AJ at the same day. So for the job at dp2j, it's not going to be whatever it is for AJ. So we can remove AJ and we put AI into it. Because AI is more, right? And then we assign this a new value to dp2i because I'm at the I. I want to know what is the minimum difficulty for the I, right? For the I need to know that. So we go to the previous biggest one, and then we find out what it is, difficulty, and say no, we don't count that one, we count the current one, okay? So we keep popping, pop, pop, pop. Every time we pop, everything we pop, we know everything in between is smaller. And when you do that, that's the biggest one, right? That's the biggest one until we hit something even bigger than you. So this is the biggest one in the current range. So we'll take that, right? And we say if stack. Then we say dp2i, which is the difficulty of the current job. If we have a stack, then we will have that, right? At the end of the stack, that's a job. And that job is higher than me, right? That job difficulty is higher than me. So for me, difficulty, because we're on the same day, right? We're on the same day. If we are on the same day, that means we shall find a universal result. Like if I go here, what is the minimum number given the previous day and the current day? What is the minimum to reach here, and I say to reach the ith job, right? To reach the ith job. And if the previous one gave us a smaller difficulty, why do I assign the current one to the smaller difficulty from the previous? Because the previous has higher difficulty than you. AI stops popping because there's something in stack is higher than you. right? Something in stack. So some job in the past has a higher difficulty, and now we check its difficulty in DP2 stack -1, and if that difficulty overall is actually smaller than what you do, because the difficulty is dominated by that, right? Yeah, it's a completely different way of thinking. Like on the first day, I want to know the minimum difficulty of complete jobs, this, right? And on the second day, I want to find a minimum difficulty to complete jobs, like from this towards the end, from this towards the end. I want to know the minimum difficulty of doing like all those jobs on the current day, and as I'm trying, right? I'm shifting the thing back, and then we have monotonic decreasing, because if I find the minimum difficulty to do some jobs for the current day, and then the minimum value is this, right? So it will be the minimum value, minimum difficulty to do jobs this, and then we have the current job coming in, okay, and then we have the minimum difficulty to do that. But we need to compare the two, because if the previous one is smaller, what does it mean the previous one is smaller? It means it takes smaller difficulty to cover that job, right? To cover that job. And what we want is to say, we'll cover all these jobs. What's the minimum difficulty? And the difficulty is determined, right? The minimum difficulty to cover jobs up into here is determined. Actually, I still don't know. The minimum job difficulty, it's a sum, right? It's a sum. And we're just saying that the previous will have a smaller difficulty. The sum of difficulty towards this is smaller than the sum of difficulty towards here. So you say I take the previous one? That I don't know, man. Yeah, I'm trying to understand what this one means. This line. Current difficulty and the previous. The one with higher difficulty than me, right? And it's the second day, right? It's the second day. If I do job until here, and if it's the second day, then difficulty will get a certain value. And if I do job until here, you're saying the difficulty of doing job is going to be the previous one. Well, each day, right? Each day you do a certain number of jobs. Now the DP is the total difficulty, right? The DP is the total difficulty, which is include the first day and then towards the second day. We include the first day. That's why we have this, right? That's why we have this. So we include the first day. So we include the first day and the second day. And I say, because on the second day, right, on each day, if you do a certain amount of job, the difficulty of the day is determined by the largest value. So when your AI comes in, DP, this one, right, A stack this one is larger than AI. It's larger than the current one. Therefore, if you keep working towards I, right, you keep working towards I, your difficulty of today does not increase. So we stay at what this level is. I stay at what this level is. So if your current, right, is become bigger than the previous, then we don't take it. We take it. Oh, that makes sense, right? That makes sense. And then you keep doing, and when you're done, you swap and you go for the next day. I might understand it, but I'll let it sit, right? I'll let it sit. Let's read this again, right? Yes. Assuming that the last number, that larger than AI, is a t. Two possibilities. Yes. Possible cutoff index. It's in between, right? If we cut off in between, yes, if the possible is in between, because they will be smaller. So that this one will be db2j, whatever j is, because the current, if the current is bigger, right? So we'll pop this smaller, we use this bigger, which is understandable, because we will keep covering up to aj. We keep covering until this. So if this is bigger than u, then we have to update u. Not update u, we have to update the current. No, we do update u. Now we update the current. Yes, because in between is all smaller, so we don't have to change. So we just change this, right? We pop this, we add this, up until we hit something that's bigger than me, right? If it's something that's bigger than me, then whatever is set there shall be set to me as well. But if I am smaller, then I take me. But if I'm bigger, I take that. I'm gonna save this tomorrow. I'm trying to write it myself. But right now, let's have some fun. So we have two. Okay, which one do we do? Let's do this one. Number of pairs of interchangeable rectangles. You're given n rectangles represented by a zero index 2D integer array. Rectangles width and height. Two rectangles are considered interchangeable if they have the same width to height ratio. Width to height ratio, so width divided by height. Decimal divisions return the number of pairs of rectangles that are interchangeable. So for this case, 3, 6, 10, 20, 15, 30. So that's 3 times 2, right? So the total pairs. Oh, holy crap. And also 4, 8. Oh no, that's n times n minus 1 divided by 2. So it's 4 times 3 divided by 2, that's why it's 6. So everybody is a pair of everybody else. So apparently the first thing in my mind is union find, right? We can union find this. And all we need to do is go through once, find the thing, right? And we can use what do we use? What do we use to do this? Find the ratio. Find the ratio. Yeah, we get a ratio. It's gonna be a tuple. We'll do a tuple. Yeah, we can do a tuple. We do a tuple. Oh, how are you gonna do a tuple? If you want to do union find, you need to label them as some value. Alright? So we are going to have a mapping. And every time we have a ratio, we'll go to mapping to check what it is. And then the current one, if it exists, oh, then why do you need union find? You don't need union find. You just use a dictionary. A dictionary will do. You just go one round down and then do dictionaries, right? And each dictionary will put count. We'll put count in the dictionary, right? So 4, 8, we reduce it to the minimum, which is 1, 2, and put 1, 2 as a key for the dictionary, and then it will be 1. There's a 1, 2, so it will be 2. 1, 2, it'll be 3. 1, 2, it'll be 4. Then I loop through them. Everything is in it. Yes. Okay, so this one is not difficult. 2001. Alright, so we just need a dictionary, which is actually, let's just go out for a counter. I love counter, and this thing is counter. We'll say counter equals counter, right? And we can GCD this. We can say for with height in rectangles. GCD equals math.gcd width and height. And then we say counter. Oof. Right, so counter something, right, plus equal 1. What is this something? That something is W divided by GCD, H divided by GCD. Right. And once we're done, we say rest equals 0. Or we can just return sum. Right. And then for value in counter.values, and we simply do v times v minus 1 divided by 2. I think this shall work. Zero. That's it. Only got 2. We can rectangles. We can add a few on our own. For instance, right, we can say 4 and then do, let's say, 5 and 25. Yeah, if you think about it, it's, well, how about we do also 4, 5 and 7, 8. How about this? Gobble gobble everything. Yeah, sounds about right. I mean, I don't know how fast this GCD is, but I think overall it should be fine. Oh, no, it should be this. Why so slow though? I mean, I remember GCD is slow for, you know what? Let's do the GCD ourselves. How about this? We will do GCD AB. I don't use the math. If A is smaller than B, AB equals BA. Now return self.gcd. We'll give B A mod B. Right. And then if B is equal to 0, we'll return A. Okay, so instead of math GCD, we'll do self.gcd. Still works, but let's see if this is going to be any faster. Still haven't fixed this one. Faster. So roll our own GCD is faster, as always. Yeah. Fairly easy, right? Fairly easy. Just to find the ratio of each width, height pair. Roll our own GCD, which for whatever reason is always faster in LeetCode than using math.gcd. Would be O(n) log k, right? And then say n equals to rectangles, k is equal to maximum rectangles. You know what I mean. Okay, so this one's done. I'll roll the next one. Actually, hold on. Maybe we should check a discussion. Map GCD. Choose a double. Can't even do that. Map can do ratio? Oh wow, I did not know that. Yeah, I agree. Yeah, I do think you have to GCD it. But anyway, that's not the point. We'll have to re-pick one. Oh, that doesn't matter. Matrix blocks. Have I done this before? No. It doesn't seem to be difficult. I'll do this some other time. But next time I'll do this. This is interesting. But anyway, I'll do this next time. So we will I'll try to write a solution for the stack. So I'll think about it again later today. But that'll be it. Alright, I'll see you guys tomorrow. Adios.